Hello everyone. In this section, what we're going to do is review the homework from last time. Now, essentially, this should be a very easy project. If you've been following along, if you've been watching the videos and doing the work that you're supposed to, this should have been relatively simplistic because there are no complications compared to what we've done before, with the possible exception of constraint number 3. Everything else we've seen before, and it should have been relatively easy. If it was not, and you've watched the videos, you should ask me for help. If you haven't watched the videos and it was not, then watch the videos. We've covered this information before. It should have been very clear to you. So, without further ado, let's begin. This was a homework assignment based on the Texas Consolidated Electronics Company. Let's begin by looking at the problem. The Texas Consolidated Electronics Company is contemplating a research and development program encompassing 8 research projects. The company is constrained from embarking on all projects by the number of available management scientists, which is 40, and the budget available, which is $300,000. Further, if Project 2 is selected, Project 5 must also be selected, but not vice versa. Meaning that if we choose Project 2, then Project 5 must also be chosen. And this is the special constraint that I talked about in the opening, as well as one of the constraints I distributed on that special piece of paper, dealing with 0-1 integer problems specifically. So, as always, let's begin by first examining the problem closely to determine our objective function and our constraints. So the Texas Consolidated Electric Company is contemplating a research and development program encompassing 8 research projects. Right away, we know this is key because now we know we have 8 decision variables. The company is constrained from embarking on all projects by the number of available management scientists. So here they're making it very easy. Constrained. Available management scientists. And the budget available. $300,000. So we have 2 constraints already. Further, if Project 2 is selected, Project 5 must also be selected. So this is another key point. Following are the resource requirements and the estimated profit for each project. So here we see all of the remaining key information. As I said before, this is a relatively simple project. There's only one wrinkle, and we'll talk about that in a couple minutes. But first, let's begin by entering our objective function. So we look over here, and let's maximize Z, where Z is profit, equal to all of our profit information. This is the profit associated with each project. If that project is undertaken, that is the profit we will receive. So, x1, 0.36 x1. And this means if x1 is 1, we receive 0.36 profit. If x1 is 0, multiplying 0.36 by 0, we receive 0 profit. So if that project is chosen, if it's a 1, then we receive that profit. So we continue the process. And that's what we found. What this indicates is every time a project is chosen, it's the number one. If it's the number one, it will multiply the profit number by the number one, and that will add it together to get our maximum profit. If a project is not chosen, it's the number zero. If it's not chosen and it's zero, it will multiply the profit function by zero, and it will be zero. We will not receive that money. Once we've entered our objective function, we have to do our three constraints. Constraint number one, constraint number two, constraint number three. The first constraint, if we look up here, number of available management scientists. Again, if that project is chosen, those management scientists must be used. So we have 7x1 plus 9x2 plus 8x3 plus 4x4 plus 7x5 plus 6x6 plus 8x7 plus 5x8. And we know we have less than or equal to the 40 that are available to us. That's all we've entered here. We repeat that one more time when we're looking at our second constraint, which is our budget. So we come over here and we see 60x1 plus 110x2 plus 53x3 plus 47x4 plus 92x5 plus 85x6 plus 73x7 plus 65x5. So we've entered our second constraint. So far, this is very clear and very straightforward. However, the wrinkle does come in our third constraint. If project 2 is selected, project 5 must also be selected. This is a conditional situation. If something is chosen, then something else must be chosen. In the homework or in the handout I gave you last time, I believe it's number 5 discussed similar situations to this. What this means is, in this scenario, x2 must be less than or equal to x5. What that means is, if x2 is 0, then it must be less than or equal to x5. In that situation, 0. If x1 is 1, if x2 is 1, it must be less than or equal to x5, which can be 1 or 0. Let's do it a second way. We'll make it a little easier. x2 minus x5 must be less than or equal to 0. So in this situation, if x2 is chosen, if x2 is 1, x5 must also be 1 for it to be less than 0. That's what we're showing here. If x2 is chosen, x5 must also be chosen, or it will not be less than or equal to 0. This is a conditional situation, and it's one of the special ones that was in the handout given in our group chat. So we have all of our relevant information. The next step, as always, we come over here, we click Module, Integer and Mixed Integer Programming. We open a new file. The file name is Texas Consolidated. We have 3 constraints, and our number of variables is 8. We hit maximize. Okay. Now we're going to rename our variables. The first one, proj1, proj2, proj3, proj4, proj5, proj6, proj7, proj8. That's what we've shown here. And we're trying to maximize our revenue or our investment. So 0.36, 0.82, 0.29, 0.16, 0.25, 0.61, 0.48, 0.41. There we go. That's what we've done so far. Our first constraint is scientists available. Our second constraint is budget. And our third constraint is conditional 2 and 5. Now, once we've entered all of our relevant information, we have to enter the management scientists available. So this is, again, 7, 9, 8, 4, 7, 6, 8, and 5. Our budget, again, 60. Oh, when we did our constraints down here, we didn't do our budget. That was my mistake. 60, 110. Oh. 53, 47, 92, 85, 73, 65. So entering the relevant information on the right-hand side, 40, 300. Now this is already set to minus less than or equal to 0. So all we have to do, x2, it's a positive value, 1. x5 is a negative value, minus 1. And we have all of the information noted. Because it's a selection situation, it's not integer, it's 0, 1, 0, 1, 0, 1. We continue on throughout all 8 variables. Here we go. So we've entered all of the relevant information. We have all the key information here. As always, we hit solve. And what we found is project 1 is chosen. Project 6, 7, and 8 are also chosen. Project 2 wasn't chosen, so 5 wasn't necessary. So that gives us a return of 1.86. Let's go back and edit our data. So we're looking at 1, 6, 7, 8. If we choose 1, 7, 6, 7, and 8, we have 7, 13, 21, 26 scientists used. That's no problem. If we choose 1, 6, 7, and 8, we have 60, 145, 218, 283. 283 scientists, or 283,000 is used. If we choose more than this, we're going to violate our budget. So we know right away we haven't violated any of the constraints. We're very close to our constraint here. So most likely this is the correct solution. That's what we've determined because they all have relatively high rates of return. We haven't violated any constraint. This is most likely the correct option. This looks like the ideal investment choice. Hopefully everybody has similar results. If you did not get similar results, hopefully following my example, you can see where you made a mistake. And I hope everybody, if you are totally lost and have watched the videos, please feel free to contact me. If you did make a mistake, please try to watch the video and see where that mistake was made. See you in section 2. Have a wonderful time and see you in section 2 again. Goodbye.